So the idea here will be to sort of take Jonathan's motivational intro, and I'm going to go off and talk about Worldwide Telescope in the way that I tend to think about it. And so again, the overview of the sequence of events here is we're in our second 45-minute phase. That'll be leading up to a coffee break, and then we'll do a second tutorial after that, and then we'll do some extended Q&A. And I want to enlarge on the remark that was made earlier that if you have some question or some particular data set or some particular I can see what I can use Worldwide Telescope for, please grab one of us, telescope people, and we'll go off into a side room and do some concentrated work with you. That's an important feature of the workshop, is to be able to go off into these side rooms and have further discussions. Also, I tend to talk way too fast, and I tend to skip important details, so please feel free to interrupt me and make me go back and be more clear. I'm going to do a tutorial on Worldwide Telescope, and there are really three goals at the end of these sort of first 40 minutes or so. The first is that I'd like you to feel comfortable with the idea of creating and editing and saving a tour. The second is I'd like you to feel comfortable with the idea of using the layer manager as a construct for managing the data that you want to bring into Worldwide Telescope. So I'll say parenthetically that if it wasn't clear before, the big, huge point here is that we are assuming that you have some kind of data that has some kind of a spatial extent, or even it has some kind of a coordinate extent. It doesn't have to be latitude and longitude and altitude. That you're interested in visualizing that's not necessarily easy to look at in, say, MATLAB or some other typical visualization environment. Okay. And so first is tours, second is the layer manager for data content, and then the third thing that I'd like you to finish this 40 minutes with is a notion of how the Excel plugin or Excel add-in for Worldwide Telescope works. And the reason that we went after Excel is, of course, first, Excel is an in-house, in-shop application, but in talking to geoscientists, Excel is just a very commonly used data format. It's useful if you have a fairly small amount of data that you want to conceptually see in terms of a tabular format, in terms of straightforward operations that you can make on that data. So being able to wash data back and forth between a telescope client and Excel is one of our initial attempts at broadening the appeal of the system. So and then the final underlying message here is bring us your domain-specific requirements, that quote up there. And by that I simply mean if you work with, or if you are an environmental scientist and you work with soil carbon, or if you work with phenology, or you work with bird species, you work with some kind of data set, we would love to see I want to visualize this in Worldwide Telescope, because we can work with you and create an initial entry point for visualizing your data, and then you can talk to the people that you work with and decide if that's appropriate for you. So we really are kind of offering an exchange service here where we can talk back and forth with you informally to get your data into the system. So please bring us your domain-specific requirements. I'm going to talk about my personal models of how Worldwide Telescope works. There's a triangle, there's a dual GPU, and then there's a insight in relationship to show and tell. Okay? The triangle is the tours time layers triangle, and simply that means that if you're thinking about Worldwide Telescope, then what you want to do is have a mental grasp of what a tour is, and you probably already know what a PowerPoint slide deck is, so it's an extension of a PowerPoint deck. You want to know that the Worldwide Telescope client has time support built into it. So there is a time axis in addition to X, Y, and Z. So you start out with at least 4 dimensions, and I would argue how you have more dimensions based on how you want to color up and present your data. But the time thing, the time aspect, is really important to remember. If you have time series data, that's kind of what Telescope and the Earth component of Telescope is aimed at allowing you to visualize. And then finally is the layers, which is a typical layer manager. And again, this is something that we tend to be familiar with in any kind of geospatial visualization system. You have sort of a list, a vertical list of different data layers and how those work. But those three things have bars between them, and the reason they have bars is because the features that I'm describing have to interact with each other. So if you have a layer, that layer can have intrinsic time values, and therefore it interacts with the telescope client in terms of the client's time state. If you create a tour, a given tour is a slide, or it's really a transition between two states of the telescope client, and those have times associated with them. So they also have layers associated with them, because if a tour has 4 layers checked out of 8, then those 4 layers can show up when that slide plays. Okay? The second model of how Worldwide Telescope works is the dual GPU. Jonathan showed this, but he didn't use my strange terminology. So you have a GPU in your computer that's rendering everything. Then you have an optical link to the GPU you have up here. And the point is simply that if you want to visualize three-dimensional data, you can't look at it static. It really helps to be able to grab it and turn around, because your brain processes that and creates a three-dimensional little aha experience for you. So always think of three-dimensional data as something you want to grab and turn around. And that's why tours are so helpful, because they allow you to automatically turn the data around so that you can just simply watch it turning rather than having to grab a mouse and drag it around. And then lastly, we want to emphasize that show and tell, or communicating about your project and your results and your data and your stuff, is extremely important. It's what the tours were originally designed for. I want to tell somebody about this thing that I'm so excited about. But even more important than that, to me, is to be able to take data that you can't understand and put it in here and say, now I understand it. I can see it in this system. It's a visualization engine. So now I have some insight into what my data means. So that's what we're kind of going for, is having a relevance beyond simply saying, here's what I got. It's, wow, this is what I got. I'm learning about my own stuff. Okay. Nextly, and I'll get rid of this, I'll get through this kind of abstract introduction, I think, with this slide, and we'll get down to business. Questions to think about as you're approaching telescope. Are you interested in raster data, so images that, say, are draped across the surface of the Earth, versus vector data, that's the lines and triangles and so forth, versus point data? Most of my examples today are vector and point data, particularly point data. And the reason for that is just because we have a limited amount of time. The raster data stuff is partially implemented in Telescope, but there's an SDK that's coming out that will allow you to prepare your data outside of Telescope and then import it. So when the earlier question about creating a high-resolution representation of some part of the surface of the Earth, let's say, and tiling that up and bringing that in, all that kind of machinery is coming in an SDK. And that SDK is currently in development, so it'll kind of be out in a couple months. But in the meantime, we do have the API, and we'll talk about that in some detail today. Again, if you're interested in the raster stuff, come and talk to me, because I can give you a quick demonstration and so forth. Next question to ask about your data. Is the task that I want to do with my data analytical? And this came up actually when we were talking to the folks at IRIS and at University of Washington. You might say, well, my data needs to have Fourier transform applied to it in order for it to make sense. I need to see it in the frequency domain and the time domain. So can I get my data into Telescope and then do a Fourier transform of it? And the answer is no, because Worldwide Telescope is supposed to be taking data in and not know about Fourier transform. It doesn't know about ducks, and it doesn't know about fish. It doesn't know about trees and clouds and Fourier transforms. It just knows about numbers. So what you want to think about is, my engine that's going to do my Fourier transform has to live outside a Telescope, and then I just connect up, I back up the truck, the number truck, to Worldwide Telescope, and the data goes in, and I visualize it there. I can pull it back out again, and I can do more stuff with it. But think about your domain-specific intelligence as existing outside of the client and connecting to the client. Okay, is my data cleanly tabular? This is where we get into the CSV files and the Excel. And there's multiple ways, actually, of getting data into Telescope. You have a right-click add feature that's associated with layers that are basically coordinate systems or environments, reference frames in the layer manager. And that's a way of, one way of pulling data in. You can also open up a shapefile. You can open up various different content files from the Worldwide Telescope menu. And you can also just cut and paste stuff out of Excel. So that's in addition to the idea that we'll be showing this Excel add-in that allows you to sort of carefully pre-format and assign parameters and then push data. Okay, we'll come back to all this stuff in the course of what I'm going to talk about. So if this is all kind of going by fast. Is my data time series? And this is getting back to what I said earlier, that there's a time state. The Worldwide Telescope client has its own clock. It knows what time it is in its little universe. And so you can make that time go to 30 years in the future, 100 years in the past, and you can make it play forward at some speed. You can make it play forward at 10 times, 100 times, 1,000 times. And you can make it play backwards 10 times, 100 times, 1,000 times faster. So orders of 10 time playing forwards and backwards in a given moment in time. And then lastly, do I want to communicate using a tour? And you can think of these tour slides as states of the Worldwide Telescope client with transitions built in between them. So one state is I'm standing over here, and I'm looking this way. And another state is I'm standing over here, and I'm looking that way. And that could be a single slide transition. And then I can copy that endpoint slide into a new slide and then continue on from there. Okay. Domain agnosticism I mentioned, but I'll just digress momentarily into what we're calling this loosely coupled API, Applications Programming Interface. If you're not a developer, it's not that big a deal, and I won't belabor it in this part of the talk. But the main thing is here is that diagrammatically I have the Worldwide Telescope client, and it has its own state where it's looking what time it is, how fast time is playing, and so forth. And then it has data contained in it. And it has this port here, it's port 5050. And you can run the Excel plugin that we're talking about, and it will talk to that port. And the Worldwide Telescope client will listen to what you say. If it makes sense, it will send you a message back. You can also write, for example, a .NET application that does exactly the same thing. You could do it in a scripting language. Anything that can write to this port, the appropriately formatted string, a URL, can have a conversation with the Worldwide Telescope client. That's a quick introduction to the API. Okay, so at this point, I should start up Telescope and actually do something. This is where the rubber meets the road, because it, gosh darn well, better start. Okay, so I've used the Explore menu, thank you, to open a tour, or I am doing so now. And this is the Open Data Workshop source tour. You'll notice that it's 10 megabytes. So the data that I've already pushed into this tour has been serialized in that tour file. That tour file contains a bunch of data. The exception to that is the raster imagery, which we've described as coming from a tile pyramid. And that's something we won't talk about here today. But in this case, I have some data sitting here floating out in the middle, the eastern part of the Atlantic Ocean. So just as in editing a PowerPoint slide deck, I have a bunch of slides up here. And I'll hit play, and we'll just let this thing play itself out. So while it's doing this, the points to notice are that the data is sitting there, it's being rendered, and I'm panning around it. Now, off in the distance, you see other little clouds, and this is actually the same data set. These are 4,200 molecules from a mass spectrometer analysis of water from the Congo River, which is right over here. And I've rendered that data in sort of the traditional way, that's here. This is what you'd see in a figure, a paper on organic chemistry of water from a river. And then I've rendered it in 12 different ways. Okay, so now we're running along. We've turned that data off, and I'm going to turn on a data set over here. This has nothing to do with the previous data set. This is a seismic subduction slab model on the west coast of South America, and it's got superimposed on it a bunch of dots that represent a solution to a seismic event. So that's the Chilean earthquake in, I think, early 2010. And it's showing a solution based on a bunch of seismograms for what part of the ground slipped and when it slipped. So I'm going to play it back a couple times really quickly. And again, it's showing that initial grid and then the motion along the top of the fault plane. Okay, now I threw that data away and I introduced a different data set. This is the subduction slab model, but it's the larger version of it. This is all generated by Gavin Hayes at the United States Geological Survey, National Earthquake Information Center in Golden, Colorado. So now I'm slipping over to the other side of the Pacific. And the powdered sugar, by the way, are what Jonathan was showing earlier. Oh, this is interesting. It's going to keep repeating. Okay. So the powdered sugar I was saying is a distribution of seismic events. And the green curtains are subduction slabs. That's how you get carbon back into the Earth's interior. And I'm playing the last slide over and over again. Okay. Now, if I'd been smart, I would have made the last slide static because it's kind of disconcerting to see it go joink, joink, joink like that. But this is a single slide, and it's referring as its next slide to itself. So I have a slide, it plays, it says my next slide is the next slide, usually, but I can redirect it to be the next slide is me. And then I introduce some text over here, and this text actually has a link to another slide. So there's a little bit of sort of logical programming that you can build into your tour, because if I go over here and click on this, my tour starts over again. So here I am back with my 12 versions of the same molecular cloud, molecular distribution from a mass spec. I'm just going to let this play for a second. So while this is playing, do you have any questions about what you're seeing here? I can't believe that this makes perfect sense, but yeah.
How are you positioning all those different graphs?
Good question. How am I positioning all these different graphs of that data? So let's take advantage of another important aspect of the way that Worldwide Telescope works. Give you the tour from here.
We have prepared a set of USB thumb drives with the information in the latest build preloaded. Should be preloaded actually. So there's something happened with the shipping. We haven't received the drives yet. Hopefully it will come today, later, and
right.
then you will walk away with the build that we
yeah,
here.
That's a good point. All the stuff that I'm showing will be available for you to take away. And how did I position these guys? Well, let's take a simple example. I have 4,200 different molecular formulas, and they all have carbon in them, and they all have oxygen, they all have hydrogen. So I take the ratio of hydrogen to carbon, and I plot that along this axis, and oxygen to carbon is along this axis. And I don't do any color, and I don't do any vertical, but then I just associate latitudes and longitudes with those ratios. So I'm basically using latitude and longitude as an x, y Cartesian coordinate system.
I guess what I meant was they're all the same data.
Yes.
So how are you, just very basically, how are you plotting 12
Oh, so what I did was I wrote an application that reads in this raw data, creates whatever configuration that I want, including an offset in latitude and longitude. So I just printed the same data 12 times with a different configuration each time. Yeah. Okay, so what else? Other questions?
So basically, in this example, are you using API that you were talking about?
Yeah, so in this example...
To get the data, I mean. To extract the data, you're using the API that you were showing earlier?
Yeah, so I'm using the API in this case to talk to Telescope and push the data in. So I have a separate application, that's my domain intelligence. It generates the data set that I want to look at, pushes it into Telescope. And then I rerun it and push it out into Telescope, but it shows up over here because I changed the offset. Yes?
It seems that everything is in lat long. Is that do you have to prepare all the data to be in lat long? You can't use any projected coordinates?
Well, that's basically an area of active development. What we want to do is sort of a holodeck concept where you just have a Cartesian space with no Earth tiles underneath it or anything. It's just a X, Y, Z space that you're in, and you can bring your data in and do it that way. So this is kind of a precursor to having that idea bulletproof.
Rob,
yeah.
we support Cartesian, arbitrary Cartesian coordinates today, right now. Now, the one thing that's the new Excel plugin, the new Excel plugin doesn't support the Cartesian's coordinates in terms of mapping the columns from the plugin, but you can basically just do the cut and paste a version of that, or the load from a file directly into Cartesian coordinates. So the idea of these reference frames is, say for instance, we'd take something like the playbook of the Super Bowl, right, played on a coordinate system of the football field. and that all the plays are, the X and Y offsets of the players where the players are sitting. And you could have a spreadsheet of that, and then all you need to do is take the coordinate, create a new reference frame on the football stadium where you figure out what the latitude and longitude of that corner is, and then now you can take this XYZ Cartesian coordinate system and plot it within that space, and so it offsets it to put it into the rest of the universe. And so what you do is you can have either a Cartesian space or a spherical coordinate space, and then you tell it how that fits into the rest of the universe. So you can have just arbitrary Cartesian space. What Rob was talking about is you could creating a kind of blank emptiness where it's just a raw canvas with no geography associated with it all, and that's something we're going to provide another sandbox that has nothing to do with geospatial at all, in a empty Cartesian space. But essentially, you could emulate that yourself today by just selecting no image set as a backdrop.
Thank you.
Let's see. I'm going to move back over to here, and I'm going to again pause the tour and pull back and go over here and just give you a quick example of the extent of the data set. So there are, I think, 3 or 4 different subduction slabs over here. 1, 2, 3, 4. And then this one here is built up of 3. So if we've covered all the questions so far, are there any other questions up to this point? Yes?
How did you create the curtain data?
How did I create the curtain of data? So the researcher that I collaborated with on this has generated XYZ files. So he has just arbitrary latitude, longitude, and depth. And so when I imported these guys in, I had to just configure Worldwide Telescope to read that. If I come in close enough, you'll see that those are actually points. So the curtain effect is just a high density of spatial points. Yes?
You can add there the data labels.
Can I do labels?
For example, of the graphics, when you will need like labels there in 3D. Or
Yeah. Currently, so right now I'm editing this tour. I can take, let's just do a shape here. I can create a shape that's.
So the label part is almost like during PowerPoint. You can add anything.
Okay, so I've created sort of an arbitrary guy here. And I'll just try and make this make sense. Okay.
Is that your question?
So I've backed up a little bit. We'll see if it shows up. Hopefully it shows up. Okay.
So you were just showing the concept.
Yes.
So that's just a, yeah.
But for example, if I load an shape file, it already have its associated labels for different feeders. So I can visualize that.
Yeah, the shape files that I've been working with don't have text labels on them, and I haven't worked with that. So we could. Jonathan has a comment too.
You can
Yeah,
hover,
that sounds interesting. Yeah.
you can hover over.
Oh yeah. Hover. You're right. Choose one color. Hover.
So one of the philosophies that I took in this, and maybe because of the idea that we were trying to research, something new. A map, when you buy a paper map, it has to have every single icon and text and symbol and everything else on it, because it's a paper map. You can't say, "Oh, what's that?" Right? And but when you have a dynamic computer-generated representation, you can basically say, "What's that?" and point at it, and then hover over and get what it is. But sometimes you can't see the forest because of the trees, because you have a forest of these markers and everything like that. And I sort of wanted to be, if I'm going to use a comparison, when you go into Google Earth and turn on a whole bunch of layers, all you can see is lots of crap all over the imagery in the data, and you can't actually see anything useful by the time you have all this junk all over it. And so to a certain extent, I kind of reacted viscerally against that to basically show you just the visualization you're trying to see, and then you hover over it to get the example. Now, the counter is like, for instance, our sky. When we did that, we don't have any constellation names or star names or anything on the sky because we wanted the sky to speak for itself. But you can find out any of that information just by pointing at what you want to look at. And then we had our context bar at the bottom that showed you the interesting things that were in the area of your field of interest, and then you could hover over any of those and see where the markers were for that. And so we kind of have this idea that that labels are hidden until you bring them up. And philosophically, some people don't think that way, and they actually like having the labels everywhere. And I apologize that we're moving to be able to let you do that if you want to, but we come from a history of trying to make that as hard as possible to make people think more the way we do. But
so this is what I call mind swap. Not only you learn from us, we really wanted to learn from you what exactly you wish these tools can do for you, because the tool is not designed originally exactly with your requirements in mind. We didn't have the full knowledge of those. So do let us know of this kind. Even the most naive question could stimulate something good.
That's a good example of what you just asked about putting labels up there. If you can come and talk to me and explain to me more about what you have in mind, then I can try and incorporate that into our thought process and what the people would want who would be using the system. And this gentleman had a question here real quick.
It's related to his, if like that curtain. So there's a possibility that if I hovered over one of those,
if I hovered over one of those data points in that curtain long enough, maybe eventually it would be set up so I could see what the numbers are that are creating that, or maybe jump from that to the data set that is generating that.
Right.
Is that what you're talking about?
Yeah. So let's just in fact, that's a good segue into what we'll show here. So I've started Excel, and I'm going to show what the worldwide telescope layers look like currently. So you'll see here that all I did was click on the layer manager and then select layer. It's inviting me to select one. Here under the Earth, there's all these molecular clouds, molecules, molecules, molecules. And then down here, there's a slab model. That's the red one we saw first. There's the slip, which has a time component. And then there's a bunch of subduction slab models here. So I'm going to go ahead and take a random... Yeah, we'll look at the slip model next. So I've selected molecules 4, and I'm just going to say get layer data. So Excel has now connected to Telescope, and it's gone and grabbed 4,161 values. And these have headers, so there's a latitude and a longitude, and there's an altitude, magnitude, which is how bright the blob is, bright the dot is, and then there's a color here, which is, in this case, it's rendered as sort of 4 hex numbers in a row. So there's opacity, and then red, green, and blue. But you can also, I'll give an example in a minute, where you can also show putting a different format in for the color. So great. We've grabbed some data out of Worldwide Telescope. I'm going to go to another sheet here. I'm going to do the same trick. But this time, as was suggested, I'm going to ask for the slip data. And you'll notice that this data has a start date and an end date. So again, I click on the Get Layer Data, and I will... Okay, so let's go over this. There's latitude, longitude, depth, start date, end date, and color. And what I did with here was I created the initial rectangular lattice of dots, and then each of those dots has a persistence interval. It lives for a certain amount of time, and when it stops living, then it starts to become an animated dot, and it moves up, and it's in the slip direction. So there's a sequence of copies of the data that correspond to the different time slices. Okay? And then finally, let's go grab one other data set here. Okay, hypocenters main, that's some of the earthquake data. We'll get that. I notice that this has dates associated, I'm not sure what that is, but longitude, latitude, depth, magnitude, that's the magnitude of the earthquake, and then an error. And the error is just a column that's not used. So you don't have to have a perfect correspondence between what you visualize and what the data looks like. Okay, so there we have sheet 1. I'll just rename that molecule. Sheet 2, slip event. Sheet 3. And then just for fun, we'll do one more. Whoops. Sorry. I'm going to create a new sheet here. Okay. Never mind. I'm going to skip that. So before anything else bad happens, I will save this Excel spreadsheet. Okay. Now I'll go over here and I'll abolish Worldwide Telescope. The Worldwide Telescope shut down, but I've recovered my data to these 3 layers here. So let's go back the other way. Let's play it. Go in the reverse direction. Here's Worldwide Telescope. There's a view menu here. By the way, these menus are split. There's a sort of a big part that has the text written on it, and then there's a smaller part. The smaller part, in the case of view, I happen to know, has the show layer manager. So over here in the Earth, there's a moon and there's the International Space Station, but there's nothing else sitting here. And so my objective now is to take data from the Excel spreadsheet and push it back in here. So here's the molecular data. That's Control, Shift, and then arrow keys to select the sort of rectangular block. Okay, so I've selected some data that I want to view in Worldwide Telescope. How do I get it there? It's sort of a 3-step process. First, I go Visualize Selection. So once I have something highlighted like this, I click on Visualize Selection, and it brings me into this dialog here. If I go up to the very top of my data, I notice that I have a latitude, longitude, altitude, magnitude, and color. Which for some reason weren't showing up, but that's okay. And it guessed that that longitude is latitude. So let's change its mind and say, no, longitude is, lat is latitude. Okay, so that's correct. Long is longitude, alt is altitude, mag is magnitude, color is color. So it guessed at the mapping between my column headings here and the Worldwide Telescope attributes. So that's great. Now it knows how things are supposed to be set up. And then the other thing I want to do is take a look at these other 2 tabs. Well, this is about time, so it's not important at the moment. And then this is going to make everything red, but I've already got a color column, so it's going to supersede the red. And then lastly, down here under scale factor, we're just going to keep it at 1, and we'll see what happens. Okay? So this is my configuration step, step 2. Step 1 was to highlight the data. Step 2 was to configure the data. And step 3 is to go down here and push View in Worldwide Telescope. And so now there's a little white dot down there. Oh, it's even doing a hover text. And here's the data set. But you'll notice that it doesn't look as pretty as it did before. It's all blurry, and that's because the default scale factor that it used was too high. So another important feature of what we have going on with this Excel plugin is that there's a dynamic connection between the state of the plugin and the way the data is rendered. So if I go over here and select a different scale factor, so a smaller scale factor, then it should have rescaled that data. In fact, it's now a little bit too dim, so I'll just take one more shot at it. I think it was there. A little better. And one more shot at it. Since it's 0.0625, I'll go to 0.125. Actually, I can try to do this too. Okay. So there's our data. It's been rendered, and so now we're coming back to Worldwide Telescope from Excel. I have a side data set here to show because we talked about well-known text. If I can find it. Okay. So this data over here, I'm going to do the exact same thing that I just did, except instead of having latitude and the longitude column, I have a geometry column, which is a well-known text indicator. And so what it's going to do is it's going to go through this column and it's going to look for that keyword and decide if it can render that or not. So I've used polygons. So I'm going to generate 3 polygons that are different colors. So here's an example of using actual color names. And then I'm providing a separate column for the altitude of those polygons. So again, I select the data. I click on the Visualize Selection to bring up the matcher. It says, okay, well, you have a color and a geometry and an altitude. I'm going to match that to color, geometry, and altitude. Great. The distance of the altitude is in meters. That's good. So we'll view it in Worldwide Telescope. And by the way, when it goes in, this is interesting, the Worldwide Telescope, there's our data. So you'll see that I drew squares here, and they're extruded down to the surface of the Earth. I'm going to pan away over from that red obelisk, and then I'll show quickly another feature of the Excel add-in. If I highlight the red guy, and I say, go to Viewpoint from data, oh, it doesn't like to do that for geometry. Okay. Let's try a different perspective. We'll select one of these data sets, one of these data points. We'll go to Viewpoint from data. It says, that's the data you just selected. So if it's more distributed, it makes more sense. But the point is that you can also control the state of the Worldwide Telescope client from Excel. And particularly, you can jump to a data point by just simply using that button. Okay, so let's finish this up real quick. The next thing I wanted to do was take the slip event and, so, whoops, let's try this. Maybe that's okay. Oh, because I'm down here. Okay, I've selected a bunch of data. Latitude, latitude, longitude, longitude, depth, depth, start date, end date, color, color. Okay? I'm happy with that. I'll say viewed in Worldwide Telescope. So there's all of our data, and this is how the data is rendered when you show everything at once, when you abolish time. You notice it's living inside of a plane that is fit to that subduction slab. And I'm now going to turn on the time support for this layer by clicking on this time series. And now all the data goes away, but the time range now reflects the time of that data. So I can actually drag this here, and I can move it back and forth. Okay? So again, I've imported data, time-like data from Excel. And once that data is in the layer manager here, I can enable it as time series data. And then this time slider allows me to go back to the beginning of that data set and forward to the end of the data set and play with it back and forth. Okay? Yeah.
Taking from the orbital tracks that you had shown with the telescope, where you actually had a contrail behind the
right.
planet, I'm wondering if you could actually apply that to this particular case, where essentially you're representing a displacement vector, and you could actually have your dot leave a contrail behind it, and that gives you a sense of travel.
And I would do that using a line string, because I can draw and extend. A line string is another type of well-known text where I could take a series of Cartesian points or spherical coordinate points and draw lines out between them. So that'd be one way of doing it. But I'd like
another
to know
way
if
of doing
has
it.
Another way of doing
yeah,
it.
another way of doing it is to actually set the fall off of the time so that it decays over a longer period of time, and then you'll actually see the trail of points fade behind it. It won't actually connect the middle parts of it, and in some cases, like when we have things where we have under I would say, for spatially not Nyquist sufficient samples, so that cutting a corner and driving, like we have shuttle. All the shuttles around campus, we have data for that. Unfortunately, we may have data from one building to another building, but we don't know the path it took in between. And so on that sort of thing, unless you actually, had, a Nyquist sample where you caught all the turns and everything like that to a good fidelity, then, you really can't fill in the dots necessarily sometimes to fill them with lines. But if that's a reasonable approximation of your model, you could also do that to help with the decay.
Right. So
we have like some GPS trails that look very interesting that way too, because you also can see like acceleration and how movement and when stops happen and stuff.
It's an important form of visualization of seismology.
Yeah.
GPS tracking, it's becoming very prominent.
Yeah.
Yeah.
So we have. I'm coming to the end of the first part of the tutorial, and what I want to do here is I just want to sort of. It's Rob, right?
Yes.
I want to readdress Rob's question in the way that Jonathan sort of mentioned, and then we'll break for coffee, and then we'll come back and pick up. So what I'm doing here is showing a very important aspect of the layer manager, and in general in Telescope, right-clicking on stuff is often a productive thing to do. So I'm using my right mouse button to click and bring up a series of options for that layer. And I have down here a Properties box. I'll bring that up, and you'll notice that there are several different tabbed controls here for the properties of this layer. And in particular, there's a date time control, and there's a time decay number here. And this is decay in days or weeks? Days?
Days.
In days. So right now, the time decay is pretty short. It's 8 days. And by the way, this is a short seismic event, so I've expanded it in time just for for visualization purposes. And I'm going to extend the time decay of my points to be 1,024 days. So now if I close this thing, now it's resaved the state of this layer, and I grab this time control. Now the dots never fade away. So it's not as illustrative as contrails, and like I say, there would be a way of doing this with contrails using line segments that followed behind, and you'd have to do a little bookkeeping and generate the graphics that way. But this is the initial cut. So I'll just hang on. Well, let's call it there because it's 10:50, so we're 5 minutes over, and we have a break now.